Okay, welcome to Cross Country Academics. We're going to talk about VFR navigation in the Cirrus today. I do sometimes combine Cirrus and 172, but we'll just do Cirrus because you guys are both Cirrus pilots. We'll dig into the Cirrus POH to get numbers and stuff like that when the time comes. Do you guys have a digital copy of the POH by chance? Great. If you have a copy, we'll use it at some point, not right now, but we'll get to it. We'll look up some performance charts and stuff like that to help us out. So you got a couple pieces of information on you. These are on our website. This is the cross-country flow I'm going to just walk you through today, this entire thing. Front and back, we're going to walk through it. It's going to take about 90 minutes. I've done it a little bit quicker, but it's probably going to take the whole 90 minutes, so bear with me. Cross-country academics can be it's a lot of new terms. You being both new pilots, there's a lot of stuff you've never heard before. So just trust the process. If you have questions as you go along, we're going to answer all those questions. Ask them right then. Don't need to wait to the end. Ask all the questions right then. But we're going to walk through this whole paper, a lot of new terms. You're literally building new neurons as you see this process for the first time. First time, it's daunting. Our goal is to fill out this piece of paper, be able to take this piece of paper with this sectional map out to an airplane and go fly with no digital anything. We could have a compass and fly this. That's the goal, to be able to do that. So we're going to completely plan a cross country the old school way. Line on the map, measuring true course, mad course, all those things. And then at the end, we're going to do the climb, we're going to do all the altitude calculations, everything. At the end, we're going to dig into your ForeFlight. You both have ForeFlight, right? We're going to make sure the parameters of our SR-20s are in your ForeFlight, and they're in there correctly for the numbers we're going to look at in the POH. Same things like climb rate, cruise burn, cruise speed, all those things we're going to look up in the POH based on the altitudes that we're going to talk about today. At the end, we're going to have a hard copy of this, and we're going to have a ForeFlight version, and they're going to match up pretty quick. And the goal is to show you what's behind the scenes in ForeFlight so you know exactly what's there. Because on your check ride, you're going to be, plotting your pink line on the map there, and if you just fly the pink line and not know how it gets there, if he takes all that away from you, you still have to navigate with the map, potentially, or at least VFR sectional in the airplane in our case, and know how to do navigation, basic navigation. All this information, by the way, is on our website underneath the Flight Training tab. It's about 2/3 of the way down. You'll see some documents. This is one of them, so you can grab that anytime you want. Okay, good. So when you plan across country, you have to kind of go big to small on, hey, big things I need to ask myself is can I get there today? And so what are some factors that might prevent me from getting at a location today?
Weather.
Yeah, weather, exactly. What are some other ones?
Weather, temperature,
Sure.
fuel.
Yeah, temperature and high altitude environments, sometimes it's the altitude's a factor as well. Fuel, sure, we got to make sure we have fuel, but weather is definitely one that can prevent us from going today on that cross country. NOTAMs, runway closures, things like that. I think just recently Williston's runway was closed, so knowing that is a good piece of information to have. If you need fuel at those locations, whether or not their fuel service works or not, that's a factor too. Sometimes we pick up the phone and make sure that fuel service works if I need to get gas while I'm there. But those are the types of things that prevent me from going places. So the first question is, can I get there, right? Based on the time frame I'm trying to go. So checking weather, what type of weather information do we have? What sources do we have for good weather?
Oh, we can check the METAR, the TAF.
Good, yep. What sites can you get those on?
ForeFlight.
Perfect, yep. What else? There's a couple more. Aviationweather.gov is a great one too. Gives you all the charts, whatnot.
And you call that number that's up there too.
What?
1-800-WX, or you can go to that website, 1-800-WXbrief.com.
That's right, yeah, 1-800-weatherbrief.com. Set up a profile on that for you guys. Set it up. If you set it up, your phone number's in the system. When you call that number, 1-800-WXbrief, that I used to have to call to get all my weather briefings growing up, talk to a briefer and get all the information. All that stuff's available on ForeFlight now. When you call them up, if you happen to call them, if your number's on file, it'll be a quicker access to a briefer. If you don't have it on file, it's going to be a longer wait to get a briefing from a person. And then the other one we put on the board up here every day, SkyVector, is really good too. For a quick synopsis of radar, it's really good. All right, so first, can I get there? Checking weather, checking NOTAMs is another thing. ForeFlight's a good way to check NOTAMs. There's a NOTAMs, aim.fa.gov is a website as well. It's on the sheet you can look at if you need to look up NOTAMs. I think SkyVector, I'm not sure if it has NOTAMs. There's a couple more sources on the website for NOTAMs, but knowing whether or not the runway is going to be closed when you get there, if there's TFRs, big thing as well for going into Gainesville, for instance. If there's a football game going on, you may not be able to get in there or may not be able to fly close to the stadium. You're aware of the arrival path and all that stuff. Good. And then, can I get back is the next thing. Can I take off and can I get back with the weather a few hours from now is all the questions. Same questions you want to ask. Is there NOTAMed out things in Ocala that's going to prevent us from getting back. For instance, we had a couple years ago at night, the runway closed and the tower closed. And so you have people taking off cross country thinking it'll be landing at night, and they can't land here. They got to go somewhere else. So they just didn't check the NOTAMs to realize that the runway's closed after dark because they were doing some rubber removal or something on the runway. So be sure you know all the NOTAMs on your return trip as well. Okay, good. So the whole purpose of this is navigating using VFR references. There's a couple different ways we can navigate. We'll talk about pilotage and Ded-reckoning in a little bit. What's the difference in VFR and IFR navigation? Just big picture stuff.
VFR is obviously visually.
Yeah. Exactly. Yeah, and IFR is obviously
Instruments.
using the instruments, right? You can be cloud deck, fully in the soup in the clouds, and navigate via instruments, be the great instrument panel we have on the Cirrus. But VFR is what we're discussing today, which is basically in relation to the ground references that you see. And then we have pilotage and Ded-reckoning. There's a couple of terms that we hear out there, but you know the difference in the two? That's the question. So what's pilotage?
So it would be like navigating based off of visual landmarks that you can see, whether it's a river, a railroad, a road, a lake, something like that.
Yeah.
That you know that you're going to be crossing on your trip.
Exactly right. So Farmer Joe's barn, I got the river over there. I've got whatever other landmark points, a mountain, not a mountain peak necessarily, but I think in Atlanta, like Stone Mountain is a good reference as well. Things you can visualize as you're flying around that you can easily pick up on the map and kind of navigate yourself to. Kind of a zigzag pattern, go from here to here to here to here. So what's Ded-reckoning now? What's the difference in pilotage and Ded-reckoning? What's Ded-reckoning?
Well, you would be using your heading or like the amount of time that you would use, like you would assume you would be at a certain point in a certain amount of time.
Good, yeah, based on predicted speeds
Yeah.
that we're going to compute in here based on winds and all that factors. So Ded-reckoning stands for deduced reckoning, right? DED reckoning. It's also, you'll see a DEAD, Ded-reckoning, right? But it really stands for deduced reckoning. I'm deducing my position between here and here on a straight line based on a heading and a distance and timing, based on my predicted ground speed. That's what Ded-reckoning is. We do a combination of both. We plot a line on a map, which is what we're going to do today, from Ocala to Cross City. That's going to be our cross-country planning. 53 miles or so, Ocala Cross City. Minimum 50 miles required to be considered a cross-country for private pilot purposes. So we'll stick to the above 50-mile ranges, and this is a good one to start off with. And we're going to draw a straight line, and we're going to try to pick the right heading based on the winds of that day. And then we're going to deduce our ground speed based on all those factors, altitudes we go to and things like that. Power settings that we're going to do that can vary as well. That's going to affect our ground speed. And we'll pick some certain parameters to use to be consistent with the charts and plan it appropriately. But we're doing deduced reckoning today, and we're also using landmarks, the pilotage portion, using left to right of course, kind of keeping ourselves on that line, using landmarks to our left and our right. We don't have to fly exactly over the landmark, we just have to see it so we can do a timing based on it to keep track of our timing and our fuel. All right, so let's talk about some variables that we have on the course that we fly, some variables that affect our navigation. Obviously, mag variation is one of them. Have you guys heard of that before? Okay, so mag variation, if you can explain what it is maybe a little bit.
My understanding is that it's kind of a difference because there's a difference between magnetic north and true north.
Yeah,
So you
exactly
have to
right.
adjust for that.
So did you know there was a difference in mag north and true north?
That sounds familiar.
Yeah, fantastic, good. So in our area, if you look on the map, you can actually see these purple dashed lines. There's one over the Gulf of Mexico, so you can see what one looks like right here. Look at this one, and then try to find one that goes near Ocala on the map there as well. One that goes kind of right near Ocala. And what is that? What does the line actually say for us here in Ocala?
There's your...
It's right here.
Oh, 6 degrees west.
Yeah, 6 degrees west. So look just north here. There's a line right there. It's kind of hard to see because there's a lot of terrain, other markings on the map as well. But that's the one line. That's called an isogonic line. The isogonic lines are the differences between mag north and true north. And so for us in Ocala, it's 6 degrees west. So really what that means is, if you draw up the globe right here really quickly, you got the equator here, and then lines of latitude here, and you got lines of longitude here. And so you got true north that's right here, right? And then mag north is a little bit off center to that. So somewhere over here, we'll say. Somewhere off the pole a little bit. Then you have Ocala, if you got the US down here, come out here. Ocala's down here somewhere. Ocala right there. So if you draw a line between color lines here. True north is going to be along that line right there, and mag north is going to be a little bit different, like that, because our compass points to magnetic north. And so for us, the difference in this degree right here is 6 degrees. There's a 6 degree difference in that line and this line. That's why it's 6 degrees west right there. Somewhere over, I think Colorado or somewhere, if you look at kind of the way the lines are drawn, I'll do it in purple here. If you kind of go 0 degrees west is somewhere off the west coast, out there somewhere, I think. I'm not sure exactly where, maybe Kansas or somewhere it's out there, but somewhere out there is 0 degrees. And then on the other side, it's going to be 6 degrees east somewhere, and it goes up from there on the opposite side. So that's the difference between our position in true north and mag north, is what that variation is, and that's we have to account for that in our navigation. Right? Good. Winds obviously affects our ground course as well, our heading that we're pointed to. Winds affects that, and if we have a strong tailwind from the west, we have pointed a little bit to the west to kind of navigate that line. We'll look at that. And then also compass errors. What would cause compass errors?
Metal somewhere that would deflect from the actual direction.
Right. So some of our SR-20s have a mag compass. Some don't. It's all built into the system there, the 80 Hz. But the compass error, if you're using a mag compass, is they do a scan of the cockpit and they can tell if it's 1 or 2 degrees off from actual mag north. Would be maybe 1 degree off. There's actually a compass card that's on every mag compass that shows you the difference. So if you're trying to fly a 360 mag course, it may say fly 001, so it's 1 degree off. Some of these I've seen up to 5-6 degrees off in the mag compass, but if we're using the onboard compass and the digital screens, it's not a factor for us. Only if we're using the mag compass and we're using that is going to be more of a factor. So know that it does exist and it can affect navigation if you're using just the mag compass. Good. All right, so let's go ahead and talk about some of these here. What would be a true course? What would that be if you just look on the map here? What would a true course be?
Like just be point A to point B?
Yeah, point A, point B, and it's measured from true north, really. It's kind of a hard question to answer for a pencil. Let's see what I got one here. Good. So we're going to basically draw a line from, right now, from Ocala to Cross City. So I'll let you borrow my plotter here. So Ocala is right there, Cross City is up here. So when you put the plotter on the map, put it dead center of the airport. It can be, the airport itself is a mile wide right here, roughly, the dimensions of it. So put it directly on the center of the airport and draw a nice dark line, dead center to dead center, all the way across. So use a pencil is better if you have a pencil. Do you have another one? If not, I may have one.
I got one.
Yeah, gonna borrow that one.
Thank you, sir. Yeah.
Pencil's probably better for this exercise, that way we can reuse the map and not be too cluttered up. Nice dark line, and that line you're drawing on the map right now, we're gonna measure, and we measure that off of true north, and it's gonna be our true course. And we're going to talk about how we measure from true north now. So, all right, you kind of went 2 lines there a little bit, but kind of pick that one there in the middle. And so middle to middle, nice and dark right there. We're going to measure off that. That'll be good. All right, good. And your line is good. We've got, okay, now we want to measure to true north. So what lines on this map help us find true north? And I'll help you out if you're not used to looking at these sectionals. You look kind of busy. So we got lines like this and lines like this. Do you know what the difference in those two are? Like this line is one of these here. What's that one called?
That's going to be longitude.
Longitude. Yeah, they're longer. Longitude, longer lines. They always go all the way across the pole down. So they're all equal length all the way around the pole. And then these are called lines of
latitude. Latitude.
Think of a ladder. That's what I think of a ladder. But latitude is here. And so lines of longitude is what we measure off of true north. So let's find them on the map here. Here and here, here and here. No, it's actually the tick marks. So if you look at the tick marks on there as well, this line of longitude, scaled in here, big scale here, right? You got this line of longitude. There's a 10-mile mark, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes up to there. Each one of these in a line of longitude is 1 nautical mile. Each one of these little distances right there. 1 nautical mile. Exactly 1 nautical mile. North on the line of longitude. If you go east and west, you also have these tick marks. These tick marks are not 1 mile. Not 1 mile. So don't use the lines of latitude for distance, but you use lines of longitude. These are exactly 1 mile apart, but these are squeezed in just a little bit, because if you look at it, as you get closer to the poles, these lines of longitude get closer and closer together, whereas the longitude lines are always the same length. So that's how they measured and came up with a nautical mile. Each one of those minutes on the map is a nautical mile. So it starts in at 28 degrees, and it goes 10, 20, 30 minutes. So 28 degrees, 30 minutes. Then it goes 10, 20, another one. This is 60 minutes, which is another a degree. So 28 to 29 degrees is exactly 60 miles between them. So if you didn't have this ruler here, you could actually get a piece of paper like this and draw your own little scale. 10 miles, 20 miles, 30 miles. Let's see this one, 40 miles here, 50 and 60. And you can each one of those you can draw. And that's your own little scale you can use to actually measure distances using line of longitude. As you're using this to measure distances, it's important to understand which line you're using. So always turn it over and look and see what it says. This says terminal area chart. We don't want that one. We want to flip it over. It says sectional chart. So the line that says sectional chart and then nautical miles. There's also sectional chart statute miles. We don't want that one either because we're flying in knots, nautical miles per hour. We want to use nautical miles for our distance planning. Make sense?
Yep.
Nautical miles. Do you know the difference in a nautical mile and a statute mile by chance?
1.15.
It is. Did you know that? So how long in feet is a statute mile?
5,280.
Good. And how long is a nautical mile?
Multiply that by 1.15.
Whoops. One. Sure. Let's do the opposite. How long is a nautical mile?
6,000. A little more. Okay.
Divide those two.
Yeah.
And it equals about 1.15 something.
Yeah.
That's how you get it. So nautical mile is slightly larger than a statute mile for our navigation purposes. Good. 1.15 is the conversion rate though. All right, good. So that was lines of longitude. Now we're going to measure true north. We're going to measure our true course. It's the first thing we're going to measure for our cross country here. So true course, let's go ahead and measure that. And to do that, we have to find the angle between our course and true north. So here's our course here, right? And we know that these lines of longitude point north and south to true north as well. So we're going to find this angle right here. And we do that by measuring it such that it's in a compass number. In other words, if I go northwest versus southeast, southeast would be like a 120 heading, northwest would be like a 300 heading, right? So think about a compass. If I'm going this direction northwest, it's going to be higher numbers than if I'm going southeast. So we're going to take this line right here and we're going to slide it along the route until the center dot aligns up with the line of longitude. So right here's one right here. So we're going to slide this, and once you go and take the ruler, slide it till it goes right, slide right up until it crosses that line exactly, and show me when you get it exactly on. So there's one here, right here.
Kind of busy. Okay. So that center dot goes there.
Exactly.
Okay.
Yep. Now you can put it this will work exactly right. Good. This is good too, Rory. Perfect. All right, good. So when you hold that right there, this is perfect. I want you to read the actual true course underneath the top right here. And realize we're going this direction, so it'll be higher numbers. So the line right here is what you're measuring. Where it crosses right there is your number right there. So what would that number be?
121.
Okay, so going this direction is 121. If we're going southeast, you also have this bottom row of numbers. Remember I said are higher numbers?
301.
Good, 301. Roy gets the same thing?
300.
Even? Well, you wiggled it a little bit.
Well,
Right, middle to middle of the airport. Middle to middle, right there. Try to get it really close. Pretty close there. What do you think?
Just like a tiny, tiny, tiny bit off.
Well, let's get to within one degree is just fine for our...
301.
Do you go with that, Rory?
Yeah, that's fine.
301? Okay, good. So true course is 301 for us today. That'll work good for us. All right, true course 301. So I'll put it in purple here. 301 degrees. True course. Good. How do I get my mag course now? True course, mag course. How do I get that?
6 degrees off.
Great, it is. We just looked at that, right? 6 degrees off. So what I added or subtracted?
Okay, so from the west you would add and east you would subtract.
Correct.
Okay.
So what's the moniker? What do we say to remember
East
that?
is least.
And
West is best.
That's it. You ever heard of that? East is least, west is best. This is where you apply that. East is least, west is best. So west, 3 degrees west, 6 degrees west is best. So we're going to add it to 301. So what is our mag course going to be today?
307.
307. Good. All right. That was the easy part. Now we get into the mag heading. So here's a question. I'm going to erase this. Everybody's good on this, right? How we get mag north? Good. All right. So let's talk about fundamentally what these definitions are and how they're different. Good as well. So what's the difference in true course and mag course? We just talked about it.
It's the difference between true north and magnetic north.
It is. But what did we add to it to get mag course?
6
True
degrees.
course. Yeah, that's right. 301. So mag course is going to be true course plus what?
The magnetic variation.
Mag variation plus mag var. That's how you get mag course. True course plus mag var. It's on the sheet there as well. So how do I get a mag heading? Which we'll get in a sec. We'll get later. We're going to compute this using our tools here. But fundamentally, what is it? It's true course plus mag var plus something else. What is that something else?
Wind.
Winds. Anytime you see the word heading, that means winds have been computed for that heading. Anytime you see course, winds are irrelevant. Course does not include winds. Heading includes winds. Course does not include winds. See the difference there? True is regarded to true north. Mag is always regarding to mag north. And then heading is always winds. Course is no winds. So plus winds, we said. So fundamentally, that's what the difference is here. Now we're going to talk about a couple things, because we need to determine what a mag heading is. We have to know what our winds are. This is what we don't know yet. We're going to compute those, okay? But before we compute winds, we're going to ask ourselves some questions, okay? First off, how do I get winds? Where do I get those from?
You can get them from ForeFlight.
We're going to use ForeFlight today. So go pull out one of your iPads or your iPhone, either way, and we're going to put in winds. So let's talk, at this point, we're going to talk here, here, and here. So we got KOCF. We're going to go KCTY. My handwriting is extra horrible today, so hang with me. OCF to CTY. So when I ask for winds, we're trying to figure out what our mag heading is based on winds. Is it winds at the surface I'm worried about? Winds it out? It's not. Where is it?
Your cruise altitude.
Yeah. So winds are up here somewhere, right? Mm-hmm. So winds at cruise is what I want. So the first question is, okay, what altitude am I going to cruise at? That's we have to ask ourselves that question. So if we're going westish bound, and we want to actually climb an altitude and go on this cross country, what altitude, VFR altitudes, would you want to consider for today's flight? Odds, evens, 500, even altitudes. What do you think?
Oh, I know that there's that instruments fly at a certain one and VFRs at the other, but I don't remember.
It's on the sheet. It's actually on the sheet right here. So from 0 to 179, and we got from 180 to 359.
So even. We're going west.
Even, right? So this is going to be even. If we're going westish, right? Is it even altitudes or plus 500?
500.
It is. Why?
Because it says so on the sheet.
Good answer. Because it's VFR. IFR altitudes are even altitudes. Right? So 1,000, 3,000, 5,000, 6,000, 7,000. Those are IFR altitudes. Plus 500 is our VFR altitudes. And we have odd plus 500 as well for going eastbound. Or when we turn around to come home, we're doing an odd altitude. Good. So the next question is, we are going a 301, 307 mag course, right? 301 true course. What's this based on? Is it based on a mag course, a true course? What's it based on? Which one of these is it based on? I'll ask. I'm going to ask you this in a couple months. You guys take your check route as well. You're going to be like, I
I
forgot.
would think it's on the magnetic course.
It is. Only on the mag course. That's exactly right. I showed an example later on where your true course can be westish, but when you add the mag variation, it's eastish, specifically from here to Gainesville. If you go from here to Gainesville on exactly that radial, it's going to be actually, even though it's a true course, let's just look at it. It's right here. Let's look at it real quick here. So it's going to be 355 going this direction. Is actually, because this VOR actually is actually oriented to true north, it just so happens that Ocala's is. It's a 355 true course to get there. But what's my mag course? If it's 355 true course, what's my mag course?
It'd be 6 difference.
It would be. So what would it be?
361.
Yeah, 001.
Yeah.
Agree, Roy? 001.
Yep.
So then what would be odds or evens going to Gainesville?
You'd be odd.
You would be odd. Even though my true course is 355, I go there in odd altitude because it's just over. My mag course is the only thing it's based off on. It's irrelevant. Now let's really quickly say it's a 30. We just said 3. I'll write this down. 001. 001 mag course, right, from Ocala to Gainesville for the map. Let's say I've got a 40 knot westerly wind. And I determine that my wind correction angle is like 15 degrees. And my mag heading equals, let's just say, 3, 4, 5 degrees. I have to fly heading of 3, 4, 5 degrees to fly this course. Would I be odds or evens? This is a mag heading, and our altitudes are based on mag course. But if I fly 3, 4, 5 mag heading, because I've got a huge crosswind, would I fly odds or evens? It's always based on mag course.
I would think it's going to be odd.
It would be odd still.
Because you'd be over, plus the 40, you'd be at 385, so it'd be 45, right?
Oh, hang on.
Or
So,
there's going to be an adjustment.
my mag course, the point is the mag course does not change.
Okay.
Over a decade it might change by a degree because the true north or mag north varies a little bit, but it does not change over a short period. Mag course does not change. It's still 001. Even though I got to fly heading towards the west to fly that 301 course,
Okay, now
it's
I get you.
always based on the course.
Yep, now I understand. Yes.
You good?
Yeah.
It's very important. Meaning it's easy to get wrong, but it's important to understand the concept.
So with the way I saw this, I think it was in one of them that it showed the true course, but it showed the winds and the plane crabbing into the wind.
100%.
And you paid the attention to the track rather than the direction.
That's exactly right. That's exactly right. No matter where your plane's crabbed, you're flying along a course, and the course is what these odd and even altitudes are based on.
Gotcha.
Good?
Yep.
Awesome. Good. All right, enough on that. So we know that now it's going to be in this direction going westish with a 307 mag course. It's going to be an even-ish altitude, right? Good. I'm going to erase this. At least you guys are good. Good?
Yes, that's
All
fine.
right. Perfect. Okay, so now we're going to a even altitude. What altitude do you want to go to?
You mean even altitude?
Yeah, even plus 500, right?
Yeah, 8,500.
Sure, 85. Maybe a little bit high for
Yeah, for that trip.
only
Yeah,
a 50 mile cross
miles,
country.
Yeah.
Yeah, it's an
So-
option though.
So 2,500.
25
Yeah.
could be a little bit low for this one. Let's pick something. First off, those altitudes begin at 3,000 AGL.
Okay.
Below that, it doesn't matter.
4,500.
45 is a
There you
good
go.
compromise. You good? All right, 45 to 65 is generally where I fly in this airplane,
Yeah.
in SR-20. It's just a kind of a happier. If I'm going to Kentucky, 4-hour flight, I'm going to be at 85 because I'm save gas, set the gas. But 4,500 is what we're going to pick. So 4,500 is where I want to get my winds from. 4,500 feet. So what are my winds at 4,500 feet at Ocala?
On ForeFlight.
Yep. And then we're also going to get winds at 4,500 feet at Cross City, and we're going to interpolate the two.
So, I mean, we've got 3,000 and 6,000, so split the difference.
You do. Split it in half.
35 to 36 knots.
Perfect. This is great. It's going to be great. With winds that speed, this is
Yeah.
going to be a great exercise. So from what direction?
It's from 10 degrees.
So we say 010
0
at what?
Call it 35.
35. You go with that, Rory? Did you see the same numbers?
Yep.
Yeah.
Jack, confirmed? Good? 35 knots. All right,
Split the
0
difference between 3,000 and 6,000 because we're at 4,500.
Hold on. What winds do you
Oh, I'm sorry, I lied to you. It's 35 knots approximately because
Okay.
it's the difference, but it's actually out of here? Because we've got 3,000, we're flying at 4,500, so do you split the difference?
Yeah, so split the difference in direction and
And so the
velocity.
direction, yeah, so it's
Take a screenshot of that.
35 knots, but it's, call it 200 and,
Two from the west, 270.
270 at 35? Is that good, Rory?
Yep.
yeah.
All right, 270, we're going to do that. All right, 270,
I like
35. Pull up cross city. Let's do the same thing. Because we're going to average the winds over this 50 miles, right? We just need
Okay,
one
so
number.
we're gonna go back to Cross City.
Yeah, just to see if it's a lot different, we'll average it out.
Okay, cross cities would be, it's, the difference would be, call it 33 knots,
Okay?
and out of 300.
Rory, good check.
Yeah, that checks out.
Yeah.
Good. 300, we say, at 33. All right, so now we're going to average these two to get the winds we're going to use for computations. So what would the average of these be? Rory, what do you got? The average of this and this is
Like
285 at 34. All right, so these are the winds we're going to use for our computation. Okay, good. All right, so we got our winds now. Now, I think we might have enough information to compute our mag heading and a wind correction angle. All right, so this is where we're going to use our whiz wheel. Okay, everybody who's happy grabs a whiz wheel. All right, these are fun. So we're going to grab the whiz wheel, this side right here.
That's the whiz wheel.
Yeah, and we're going to use this side of the whiz wheel. Josh got one, good. So she used this one. I was just going to show it for the whiz wheel camera here. We're using this side of the whiz wheel, and we're going to compute. Oh, and we're not quite ready yet. I thought we were. We're not quite. We have to do one more thing. We have to figure out what speed we're flying at, because if 34 knot winds, if I'm going 400 knots, it affects me less as if I'm going 80 knots, right? It's more of a crab angle if I'm only going 80 knots with 34 knot winds than it is if I'm going 400 knots, right?
Yeah.
Less of a factor from going faster. So we have to really compute our true airspeed next. So let's get out our POH now to figure out what our true airspeed is for this flight at 4,500 feet in today's case. So we got winds, and we got true airspeed is what we want next. Winds, true airspeed. All right, when you get your POH out, flip to the back. Is that it right there? Perfect. Zoom in on that. And I think, does it go 4,000 and 6,000? I think you have to interpolate a little bit.
Am I on the right page?
I don't know what page you're on, 180.
So it'll be the cruise,
You are.
cruise
Yes.
page.
Yeah, 4,000, 6,000. So page 180 and 181.
All right, so let's find the right column. Is this it here? Looks like that's it. 4,000, and the next one's going to be 4,500. Just for simplicity, let's just use the 4,000 column, so we don't have to interpolate between the two. We know how to interpolate. We're just going to say 4,000 for today's chart. Happy with that? It's going to be pretty close for us. So what variables are on that chart that make us have to decide some things?
The
One
RPMs.
is RPM and or power setting. Exactly right. So if you look at power settings at 4,000, where are we at here? 4,000 down here, right? And look at the top of the chart. It actually says, ISA minus 30, ISA, and ISA plus 30. ISA is International Standard Atmosphere. So what is a standard atmosphere? It's based on your altimeter setting and temperature.
Yeah, it's 59 degrees. Or
Good,
something.
yes, 59 degrees Fahrenheit, or what is it, Celsius? 15 degrees Celsius, yep.
Okay.
And then what's the altimeter setting for standard?
29.22? 92?
92, good. That's a standard day, So if it's really, really hot, like 110 degrees in summertime, then we might be on this ISA plus 30 up here.
Mm-hmm.
If it's really, really cold up in Alaska, minus 40, then we have this ISA minus 30. So we're gonna take the middle column, which is roughly ISA for us today. It's not too far off from standard day. So we're gonna take that middle column, which is ISA, and we're gonna roll down. What's the next thing I gotta determine? Power setting or RPM? Here we go.
Knots.
ISA 4,000 is this one. And then power setting, right?
Mm-hmm.
So let's look at what power setting you want to use for cruise.
65 to 75?
Yes, so let's pick one.
65.
Okay, Rory, you want to use 65?
Yeah, that's fine.
We could use 70 also,
Yeah,
or 75.
70.
Let's use just for
70.
today's academic purpose, let's use 65. Okay,
Okay.
65%. So 65% power. Now, if you actually flew this today, I would force you to set 65% on the cruise out and back. I cruise a little faster, 75 for going long cross country, but this is a good practice. 65%. What would be the fuel flow and true airspeed for that power setting? And ISA.
True airspeed, roughly 142 knots.
Rory, agree?
Yep.
Good. And Rory, when you get a chance, take a snapshot of that screen, and I'll use that in my video so we know what we're looking at. 142, you said?
Mm-hmm.
All right, good. 142, and we've got
11.3 on the fuel flow.
good. That's a stand. 142, 11.3. This is good. So true airspeed is 142, and gallons per hour is 11.3. That check, Rory?
Yep.
All good? Perfect. Okay, now we can grab the whiz wheel and go through this. So as you grab the whiz wheel here, flight computer is otherwise called. It's a circular slide rule, all those names. We're going to follow the directions from the top to the bottom. So the top to the bottom is little directions right here on the top there. So slide it up so you can see it. Very good. So Jack, I'll have you read off the very first thing that says do. What does it say do?
Place wind direction under true index.
Great. Wind direction we said with 285 and 34. So slide that thing around here. Yep, 285, and the true index is right there. So slide around. It's almost there right now. 285, yeah, twist both sides there. Yours is actually newer and nicer.
And it goes to,
285. Wind direction it said, right?
okay.
Good. Roy, read me off step number 2.
Mark wind velocity up from center.
What was our wind velocity?
34.
34. Yeah. So mark it up from center. So the center of your dial is here and here. So put that on any one of these lines. It doesn't matter which one. Just put it on any one of these lines. Any one of these lines right here. So slide this up and
Oh, I
down.
see.
Yeah, until it gets right on top of any one of those lines. You got it? Good.
Yep.
Now, so each one of these is 10, 20, 30, 34, you said, right?
Yep.
So if you look, it's like 10, 20, 30, 34 is what we're going to actually mark up. 34.
Okay.
So mark a dot, a nice dark pencil mark, if you got, or pen. If that pen writes on it, that's perfect. If not, we use marked pencil.
Okay.
So I'm putting it where again?
So if you count up from the center, like this is 160, 170, 180, 190. It doesn't matter what these numbers are yet. You know this is 10, 20, 30, 40 knots. You want to mark up 34.
Okay.
You're marking it from center 34 knots. So about right there, make a nice bold mark as best you can. Here so you can see it. Perfect.
Mhm.
Is that pen mark okay? Yeah, use this pencil.
There you go.
Works a little better on those slick surfaces. You good, Jack, on yours?
Yeah.
Perfect. All right, Mark, read off number 3. What step?
Number 3 would be to place the true course under the true index.
Great. What's our true course?
True 301.
Good. Place that, so slide it around, circular slide around to put that number 301 on your true index.
So
So around here. So slide this around to put 301 under true index.
Oh, I
Slide
see.
that there. There we go.
okay.
Good. Okay. Jack, when you get yours, put yours back and take a quick snapshot of it.
Now I get what this is.
Yeah, light bulb's coming on. It's good. It's good. Take a snapshot when it's marked up from center first, Jack, and then put it back to that next step.
Okay.
We'll use yours for our
Alright.
video overlays. Don't screw it up. We're all counting on you.
I'm probably going to.
All right, you're good? Yep, like that? You're good? Like that. Perfect. You see what's happening here?
Yep.
All right, good. Now, what's the next step? We'll go with Rory. What's the next step?
For slide wind velocity mark to TAS line.
Good. Here's where everybody makes a mistake. It says wind velocity mark. So point to that you just made. Wind velocity mark. Yes, point to it. Great. Slide that dot to your true airspeed line. What's our true airspeed? We computed it.
142.
142. So slide this mark down to 142.
Okay.
Down, because this is 160, 150, 140. See it there?
142.
Well, yeah, that's it.
Yeah.
Good. 142. Great. Okay, perfect. Now this is set up. So once you get snapshots of those two, right, Jack?
I accidentally had it on 142 right away.
Oh, look at you. Perfect. All right. Is everybody set? Great. Now the thing's set. Now we just read the information. So next step is what? Next step 5 maybe?
Read ground speed under center.
Perfect. Ground speed is what? Under center. So that the hole in the middle. What does it say?
Oh, like 110?
Yeah. Rory, you
Gotcha.
agree?
Yeah, 110.
Jack, good? 110? All right, 110 ground speed. What's the next step, Rory, after step 6, I think?
read wind correction angle between center line and wind velocity mark.
Great. So wind correction angle is the angle between your mark and the center. So if you can kind of see how the angles are scaled from here to here. If you go with this, is 10 degrees there, all the way 10 degrees here, 20 degrees here. So how many degrees is that?
Are we measuring from this mark on the 110, or where are we measuring that from?
Great question. So this mark is your mark right
Yep.
here. And how many degrees off of center is it?
Oh.
So this is 10 degrees, this is 20 degrees. So how many degrees off of center is it?
Like
4?
Yeah, 4.
Exactly, Mark. Yeah, you get exactly 4. You get the same thing, Jack?
Yes.
Good. So is it left or right?
Left.
Left. So is it subtract or add?
West is better.
Don't overthink that. Don't do it. I know that everybody goes there. That does not apply here.
Okay.
Yeah, because we may be going eastbound, so that doesn't apply. What applies here is just left or right. So
Okay.
don't overthink this. If it's left, then you have to crab into the wind 4 degrees.
Okay.
You with me? If it's right, you got to crab to the right 4 degrees.
Yeah.
So we're going to now subtract 4 degrees for a wind correction angle.
Okay.
See how that works?
Yep.
Subtracting 4 degrees. So winds we talked about, wind correction angle. I'm going to change it from winds to actually wind correction angle because that's actually what it is. WCA, wind correction angle is minus 4 degrees. So what's our mag heading then based on this?
303.
Agree?
Yeah.
303. Good. So 303 is our mag heading. This is actually the heading we're going to actually get up, get airborne, and fly that heading to try to maintain this course. It's going to vary a little bit because the winds vary a little bit, but it gets us pretty close to being spot on. Okay? Good. All right. Now we're finally to putting some information on paper. So we got the data that we need to start grabbing this piece of paper and start filling out some stuff. Okay? That was all the computations, which was all good stuff. So the way I do this piece of paper, fold it in half if you want to, you don't have to yet, but the same, front and back's the same thing. Okay? So I start writing my data on the top of the piece of paper. So start filling out the data on the top. So you can see I got winds from 285 at 34. It's just data to put on there. True air speeds on there, ground speeds on there. So just copy this data at the top, which just did all this work to compute. And I would normally capture it on the piece of paper as I do it, but I had the whiteboard in it for the camera. So we'll just transfer it now when we get the time. Wind correction angle we talked about. We got our mag variation on there. We got our line drawn already. The next thing we're going to do is we're going to pick some points along the route that we can use pilotage as we do our Ded-reckoning route there. Okay? All right. So the first point you're going to put on your paper is KOCF. That's our origin. KOCF. Okay? The next column over is mag heading. We already know what that's going to be. So let's go ahead and put that on there. We just computed it. So might as well go ahead and put 303 there. For this cross country, because we're not doglegging left and right, it's going to stay the same thing all the way down. But you don't have to repeat it all the way down. Just know 303 is our mag heading for this. So 303. And then now we're going to start picking some points along our route. So let's get our map again. Clean off the map as best you can. Between here and here's where we're going. And the key to picking points is you want to pick a point, roughly speaking, man, and the Cirrus is different than the Cessna. In the Cessna, we say 10 plus or minus 3 is a good rule of thumb. For the Cirrus, it goes faster. So it's more like 15 plus or minus, too much. Maybe 12 plus or minus 3 or so, 12 to 14 is okay. So longer in the Cirrus. But for today's planning purposes, we're going to use kind of 10 plus or minus 3. It's just the point you a little bit quicker as we actually fly this because we're flying a faster ground speed in the Cirrus versus the Cessna. So 10 plus minus 3 is kind of what we're going to use initially for picking points. So roughly 10 miles from the airport here. You can use your rule if you need to, but it's going to be basically the width of our VOR is between here and here is 10 miles. So somewhere inside that ring, let's pick a point that makes sense along the route. And I'll let you go ahead and try to pick a point along this route here. Something left or right of course that we can find on the ground that tells us, okay, I'm about on course if I fly to this side of that point.
Within 10 miles?
Yeah, something inside 10 miles. Somewhere around in this area here, that's what we're looking at.
I mean, I know WEC is there.
The WEC is there. And how far is the WEC?
4 miles.
It's about 4. It's not even on the map though.
Yeah.
So you want to pick something that's on the map we can visually see and use the map as our backup. So I'm just going to give it to you because it'll be easier and you kind of see why. If you look at the right side of the route, there's a road that goes kind of a winding road. It's a little bit wiggly, got a couple of humps in it. The second hump in that road is going to be our first point right here. So that hump in that road with a little tower next to it is our first point. So translate that to exactly where we're going to be a beam it and mark it right on the route just like that.
Okay.
A beam of the tower right there, right along that route. Is going to be a beam of that tower, which is along the second hump in the road. And you can see that. We'll show it to you. It's actually very easy to see. And that tower is exactly in that spot. These maps are surprisingly accurate. Every bend in the road is there. Every double back on a river is there. It's really accurate. These maps are really good for that purpose. So trust the map and what it looks like on the ground. All right, the next point we're going to use, if you look 10 miles up the road a little bit, you have this big point right there. What's that?
Williston.
It's Williston. That's a pretty good point. We should be able to see Williston being 3 miles away from it. That's a good second point. So now the question is, where along our route are we going to pick? Because I can see Williston from probably 5 miles away. I'm going to fly past it and I can still see it. So what I use for along that route is going to be, Mark, you could either pick a ground reference that you're seeing right now. North-south road would be good as well. What I've seen that worked pretty good here as well is looking right down, as I'm flying past Williston, looking straight down my wing down the runway. It works pretty good. So if you kind of draw a straight line off runway 5 and 23 right to your route, that seems to work pretty good right there. Draw a little line. Yep, perfect right there. Good. That's our second point. Third point, let's go somewhere between here, 10 miles away or so, 7 or 10 miles away.
Bronson.
Yeah, somewhere in that area. So there's several things in this area, 10 miles right there that you can kind
road
of
that
pick.
intersects right there. You got 2 roads that intersect.
Yes, that's actually a pretty good one there. So that's a road and that's a road as well. Yeah, so that's good as well. That's a good road to use. You can use that one.
So here.
I've used a lot of things in this area. So yep, here and here. Yeah, that's good right there. So transpose that right along the route, or as you cross the road is probably the best way to put it. As
Or
you're
just
crossing,
right there.
Yeah, as you're crossing that road, you'll see the crossroads. As you're crossing that road is a good place to mark. These are points that we're going to use accurate timing. So when you get over the point, mark your time and then you can write that down. So roads are really good for that. Crossing a road is. All right, keep going up. What else we got?
Got another airport here for,
What's it called?
is it Trenton? No.
Well, maybe in the town of Trenton. Let's see.
Windy Acres.
All right, so when
And
I
White
first
Farms.
White Farms, which one?
There's 3 airports that are there.
Sure. So what's the difference in a circle R versus a filled-in circle with a line in it for an airport? Difference in this circle R versus this?
Public versus
It's a good guess, great guess. In this case, it's actually not. I think it's a private field.
Yeah, they're both private.
Yeah, it is. So Windy Acres, nope. This is another, what's it called? Manatee?
Manatee.
Yeah, Manatee. Manatee is actually a private, it's paved. It's a paved strip. It's a hard, I shouldn't say paved, I should say hard surface. It's a hard surface strip is why it's actually filled in there, right? So you would think you should be able to see that, right?
Mm-hmm.
You ever flown over that? You seen it? You cannot see that. Me and Allie, one of my first students went out, and I took the airplane. I got the airplane. And I circled that thing 3 times before I found it. It's a little gravel strip next to a road that you can hardly see. There's big trees next to it as well. That one, I'm with you. I was suckered in at picking that one time. It's not a really good point. But there is a town right next to it that's really easy to see. Let's just pick the town of Chiefland. It works really good. And
right before.
yeah, there's a little bit. Yeah, it's a little cluster of houses in the trees there. You see on the map, it's yellow, little yellow clusters. That town is actually pretty easy to see. So right when you're being that town, mark a point. Good. And then next one, we'll pick one more before we get across city. It's actually pretty close to this one, but
The water.
yeah, the wall right here.
Fawning Springs.
Well, it's actually is that a river?
Yeah, it's a river.
Up there?
It's is it the Sewanee?
Sewanee's further north.
Oh, really?
Yeah.
No, I think that's it. Look
Right here?
here.
Oh, yeah, you're right.
Yeah,
It
so that
bends
is
around.
Yeah, that is a Sewanee. So let's pick that hump on the Sewanee River that we're actually flying over. And I promise you that hump looks just like that. And you can correct your course because you can see that thing from 10 miles away and go, okay, fly with a hump, I'm good to go. So that's the hump. And then we got cross city. Good. Now we're going to transfer those points to the cargo here. Okay, how are we doing on time?
Good.
All right?
Like an hour.
I've been talking an hour already?
49 minutes.
Oh, okay. Not too bad. All right, so back to the map. We're going to name these points. So on the left-hand side, we're just going to make rough names for these. So the first one, we can call either a tower or a road. What do you want to call it?
Tower Road.
Tower Road. Good. So right, Tower Road is the first one. The next point is something else. We call it Wilson, I think.
Yeah, Wilson.
So X60 there. Good. What's the next one?
That was the road that you crossed directly over next to Bronson.
Is that Archer Road?
Too small of a road, probably. Yep, it actually is Archer Road. Yeah. There's actually this one. This is a, that's not a road here. That's not one either. It's this road right here you want.
This one?
It's this one right here. See that
Okay.
road right there?
Yep.
Yeah, Archer Road is actually what it is. So you can call it Archer Road if you want. Archer Road. The next one should be the town of,
Chiefland.
yep, so I'm just gonna put town there. I don't care what the name is. I just know I'm looking for a town off my left. And then what's the next one?
Riverbend.
I just put river. It's the only river out there in that location. And then we can put Cross City, KCTY. Perfect. Those are our points. This is what they look like all the way down. Good. All right. Now let's get the distances of those points, each one of them. So take your, and it's the distance between each point there, making sure we're looking at the, not that one, but the sectional chart in nautical miles. This is between each one of these points. No kidding, in the middle of the airport to that, and then from this point to that point, exactly like that. Yep, in the middle of the airport. How much you got?
7 miles.
Okay, we'll get an agreement.
About 7.
7 even, want to go with? Good, I liked it. So distance is going to be 7 miles to the tower. So in your tower right there, there you go, 7 miles in the right column. Perfect, 7 miles. Good, X60, how far is that?
10 exactly.
Okay, I'll let Mark finish on that one.
Yep.
Good, 10. Perfect. Give me your phone. Camera option, I'm going to take a photo of this.
Archer
And-
Road I have at
It's like almost 11.
Okay,
right around 11.
11 to Archer. How about that? And then from Archer to Archer
Chiefland.
Road. Sorry, Archer Road to the town of Chiefland. Yep.
As 10.5 miles. Call it 10 miles.
I've got like 10.
Yep. You may
I think
mark,
it's just
you
where
may
my
mark the
mark
point
is.
just a little bit different. Oh yeah. So right here, maybe to the left a little bit, right there when you beam it.
Mm-hmm.
Right at 10.
Okay.
I like that. Right at 10 is good. This is a short one here.
6.
Yeah, 6.
You like 6? Okay. And then the last one.
9.
Yeah, 9.
9. I like it. Good. So let's add all those up. 7, 10, 11, 6, 9.
53, 54.
28, 38, 44.
What'd you get?
53.
53. Good. Now give me a total distance, because you can, just as a sanity check between here and Cross City. The whole distance, just to make sure it all matches up nicely.
Yeah, I got 54.
Roy?
Yeah.
54?
Yeah.
Close enough.
About.
Yeah, it's close. So those are rounding errors between each of those points right there. Okay, not a huge deal, right? Okay, now we got to go timing. So let's think about the next thing is is timing. So let's talk about timing of those points. So how long is it going to take me from the Ocala to the first point 7 miles away? The way I'm going to do timing to this point is we're going to now reference a different part of our POH because we're at this part right here. We're right here now. So we're going from Ocala to our first point 7 miles away. And so is my ground speed from here to here going to be 110, you think? Probably not. Why? What is my climb speed?
Yeah, it's 105. Is it?
Yeah, we're climbing at 105 roughly, right? So instead of me spinning the winds for 105 at the different varying winds on the way up, let's just look at the POH and see how long it's going to take us to get to 4,500 feet, roughly, and how much gas I'm going to use to get there as well. So let's see if we can find that on our POH chart. It's going to be, I think it's the time to climb chart, at least it is in the 2
This.
climb charts. What does it say? Can't see it.
Time,
Time, fuel, distance,
to
climb.
climb.
Good.
Page before.
Great. So do you have to interpolate between like 4 and 5,000, or what is it? Great. So let's look between 4 and 5,000. Thanks. And I'll snapshot this one as well. Look at these photos after. All right, between 4 and 5,000, we're looking at, let's see, climb speed is roughly gives you there, rate of climb, good, time in minutes, and fuel US gallons is what we're going to use, and the distance is pretty good too. But distance, we're actually going to use, the distance is exactly our first point because it happens about the same time. Leveling off, first point happens about the same time. So let's just look at the time to climb to 4,500 feet. What time would you use for that? Minutes of time.
I'd guess a little over 6, like 6.2.
6, yeah, 6.2, whatever. We go 6 plus 0 is good. When we do time, I like to write it minutes and seconds like this. 6 plus, 15 seconds or so. I like to write the plus sign there. It keeps me from getting messed up between 6 hours, 15 minutes, and then 20 seconds. I don't know where the colons, what's what. So for military time, some of my military throwback days when I used to do low levels and stuff, we write minutes and seconds as a plus between. It's a technique, it just worked for me. So you can use that if you want. So let's write 6 minutes, and you said it was point what?
Well, split the difference between this was 5.6 to 4,000 and 7.3 to 5,000. So split the difference.
Yeah, let's go 6 even. 6 plus 0, 0 is perfect for this.
Okay.
Yeah. So 6 minutes, 0 seconds is going to be the time to get to the tower. 6 plus 0, 0.
Can I
Okay.
put that here or the next line down?
It's a great question. The next line down, that's a fantastic question. Used to, what I would say is just add a blanket 2 minutes because you know you're going to climb slower, and then use the ground speed this time for that first point. But I've now said let's just use the chart, figure out what's going to be the first point, and then we'll go from there, which works out pretty good.
Okay.
All right. Now from X60, the next one is 10 miles. So now we're going to use the other side of our whiz wheel now. So flip the whiz wheel over, and more academics on the whiz wheel, which is super fun. Flip it over to the other side. There you go. Yep, good. Now, let's look at how this is designed. The thing to remember about this whiz wheel is the inside ring is always time. It's always time. Because we measured, the speed is miles per hour. So it's something over time. It's distance over time. So the bottom of the dial there, inside, in this case, the inside ring is always time. And if you look, it stops at 60. It's 60 seconds or 60 minutes, which is 1 hour, or 1 minute if it's, 60 seconds. So it's something for like 55, 60 seconds, 70, 80, 90 minutes, 90 seconds. You can do minutes or seconds, but the inside's always time. So just remember that. Now, we're going to set the ground speed of 110. So it's 110 miles per 1 hour of time. The 1 hour of time is your big arrow on that right there. Yep, you got it set. So this is 90, 100, 110, 120, 130, 140, 150. So set 110, which is this one, looks like an 11, but that's what we're going to use because we can add a 0. So
Okay.
your arrow right there is 60 minutes, right? And then put that on the 110 right over here. And we're gonna set one. This is 10. This is 11. So this is 100 knots, 110 knots, 120 knots, 130 knots. Put it 110. There you go. You got it set. All right, you got it, Jack? You got it?
Yeah.
Good. Now, so let's just think logically. This is where it's going to sit for all these computations. Let's think logically for a second. How far am I going to travel if I go 1 hour of time? Look at the top. How far am I going to travel 1 hour of time?
110.
110 miles. Pretty simple, right? 110 miles an hour, or in this case, 110 knots, nautical miles per hour. 110. How far am I going to travel in 30 minutes of time? Find 30 on the inside scale. Find the number 30 on the inside scale, right over here, and tell me what the outside says. 55 miles, right? 30 minutes of time. So now I'm going to reverse it. How long will it take me to go 55 miles?
30 minutes.
30 minutes. How long will it take me to go 40 miles?
Almost 70.
Oh, take a snapshot of that, by the way.
Yeah.
Good, thanks. How long does it take me to go 40 miles?
Like 74.
22 minutes.
22 minutes.
22 minutes, yeah.
So miles are on the outside.
Oh, I see what you're
Time is always on the inside. So miles, let's find 40 miles, which is where? Right here? Tell me how many minutes it takes,
Oh, I
roughly.
see. All right. Yeah.
How many, Rory?
Almost 22.
22, yeah, roughly 22. Good enough. Yeah. How long does it take to go 20 miles?
11 minutes.
Good. Let's back it off one more. How long does it take to go 10 miles? That's one of our computations here. 10 miles takes how many minutes? And when I do minutes, you can go minutes and seconds. If it's halfway between, I'll go minutes plus 30 seconds, what have you.
I'm sorry, what was the question again?
How long does it take to go 10 miles? Yep. How many? What does it say?
55 is what it says.
55. So let's think about what 55 is. It's actually 5.5.
5.5.
So 5.5 minutes is what that says. So how many is 5.5 minutes? How many minutes is that? 5 minutes. 0.5 is 30 seconds.
Yeah.
So 5.5 minutes is 5 minutes and 30 seconds. So I'll write it 5 plus 30. So let's go down here. X60 was 10 miles. So it's going to take us 5 plus 30 minutes to get there. You with me?
Yeah.
Good. Let's do 11 miles. Very similar. What's it going to be? 11 miles in this case takes me exactly how many minutes? 6 plus?
0.
0. Yeah, 6 plus 0, 0. Write that down. Good. 10 miles again. We already did that one. So that's 6 minutes and what? We said 5:30. So right, 5:30. Yep, good. The next one is 6 miles. Look on the scale. Tell me how many 6 miles. How many minutes? Six miles is on the right over here. Yep, 6 miles outside scale over here.
Oh, half.
Oh, right, 3 plus something. Is it quite a half or is it less than a half?
Less than.
Okay, so we could write 3 plus 20 if you want.
Okay.
I keep it in 10-second increments because to the second it's just not really practical. Good, 3 plus 20, is that about right?
Yep.
Good, and then the last one, 9 miles. Let's see it.
Basically 5
Okay.
minutes.
About 5 minutes.
Almost 5, yeah, I like it. So 5 plus 0, 0, yeah, round up, that's good enough. Yeah, 5 plus 0, 0, perfect, good. Now we got all the times there, let's add those times up. Almost done.
22.
Almost done, guys.
3.
With
31, 20. 31
Okay.
minutes, 20 seconds.
Good. And for a Cirrus, it's a long time. We got a huge headwind today.
Coming back's going to be quick.
Huge headwind coming back. What'd you get, Roy? Same thing?
Yeah.
You just guessing? Did you get the same thing?
I could've just-
31-20. All right, we all agree.
I could've
31-20.
just made that up.
No, you sounded confident, man. I'm going with it.
31-20. Good. We'll write that down. Perfect. And okay, good. That was the total time. Now we're going to actually do fuel. So going back to the chart, which I think we took a snapshot of, time to climb. How much fuel did it take us to get there on that time to climb chart? I didn't write that down here, I don't think. I forgot to write that down.
To get to 4,500.
Yeah, time to climb was 6
Good
minutes, we said.
2 gallons.
Yeah.
2.0?
Between 1.7 and 2.3. So
Fantastic.
2.0.
And 2.0 gallons. I'll put that here as well. 2.0. So 6 minutes and 2 gallons to get there. Okay. So that got us fuel to this point, 2 gallons worth. Okay.
Yeah.
Now, on this one, on the charts like that, it's always important to read the notes. So look at the very top of the page there and read those notes off, Mark, if you would. Kind of skim through them. Tell me the highlights of those notes. Specifically, the amount of fuel on the ground we use for start, taxi, and takeoff.
Add 1.5 gallons for start, taxi, and takeoff.
Perfect. So, on your top line there, right here in fuel, very top line, we're going to put 1.5. Very top line. That's going to be what we do on the ground getting out of there. On our next line, which is going to the tower, we're going to use that 2.0 gallons. Okay, good. Now, for the rest of it right here, for the rest of this whole part right here, we're going to use our 11.3 gallons an hour and the time it takes to get there. So hang with me. So now we got to ask ourselves, how much time does it take to go between the tower and Cross City? It's going to be this, and this added up. Those numbers added up there, because I've already got it for this one. I don't need to add this 6 minutes. So it's a total time minus 6 minutes is what it's going to be.
25 and 20.
25-20, great. So we're going to go 25-20. Just write that down for a second. 25 minutes, 20 seconds. At what ground speed? I'm sorry, at what gallons per hour?
11.3.
11.3 gallons per hour. Good. So let's put our whiz wheels to work again. And I want you to put 11.3 gallons now per hour. It's not distance per hour now, it's gallons per hour. So put that big arrow on the 11.3 mark, which is actually pretty close to where you're at.
Yeah, it's not much
Yeah,
different.
11 point, that's 11.1 looks like. Slide it over 2 more ticks. There you go, that's 11.3. Let me know when you're set,
Yep.
very good. Snapshot when you get there, Jack. 11.3, this is gallons now, gallons per 1 hour of time. Gallons on the outside, 1 hour times inside. And we're gonna go for how many minutes? 25 minutes and 20 seconds.
Yep.
So on the inside scale, find 25-20. Somewhere in there, 25 minutes and 20 seconds. And then tell me how many gallons I will have used.
Just under 50.
Okay, let's look. So we know 1 hour is 11.3 gallons. So I'm gonna go 20 minutes, 20 point what? 20 right here roughly? Oh, sorry, was it 20? No, sorry, 25. 25 minutes and 20 seconds. So this is 25 and a half minutes. 25, 20 is about right here. So what is that right there? It's gonna be that number right there. 25 minutes is, outside is distance, inside is time. We're looking inside now. 25 minutes right over here. 25 minutes and 20 seconds. What'd you get, Jack?
40.
So I'm in liters.
Yeah, no, that doesn't make sense.
Great comment. Don't worry about that. So that's, I don't even know how to, that's converting, that's a different, to convert gallons to liters. That's what that arrow is used for. Don't use it in this case. We're still doing gallons per hour in this case. And those outside scales still work. So let's look at inside time. It's gonna be 20.
So it's just short of 5.0.
Good, what'd you get, Mark? Same thing?
Yes.
So if it's just short of 5, I always round up for gas. So we're gonna go 5 gallons of gas. Now that's from here all the way to here.
I think
5.0
you're
gallons.
first interpreting it as 50.
Yeah, you were. Yeah, 50, but you're not going to be 50 gallons, right?
Yeah.
It's only
I was
5
like,
gallons.
This doesn't make sense.
So we use 2 gallons here in the climb, 5 gallons there going the rest of the way, and that's our fuel, 5 extra gallons right there. So 5 gallons for the rest of the time, 8.5 gallons. So we should burn 8.5 gallons to get to Cross City if we took off and went straight there. Make sense? Whew. All right, good stuff. 8.5 gallons to get there. Yeah, the descent. Let's talk about the descent real quick. I'm assuming that's the same fuel burn in the descent right here. Just assuming it, because you're going to be probably pull back power a little bit and cruising down a little bit faster, so it's going to help you in the gas. So 2 gallons here, 5 gallons here, 8 plus the 1.5 on the ground, 1.5. That's your fuel burn. That's your 8.5 gallons total to fly this cross country. How much is required for us to have on the airplane to legally fly this cross country?
You have to add, during the day, you have to have at least 30 minutes worth of time. So if you're burning 11.3, you need to add, 5.5 to 6, call it 6.
How about that?
Yeah.
Good. 30 minutes of fuel based on what? 30 minutes of fuel based on?
Daytime?
Yeah, yes, daytime, right. It's actually based on the cruise fuel.
Yeah,
That's what I was
cruise
getting
fuel.
at. It's not
Okay,
based
so-
on takeoff fuel, which is a lot more. It's based on cruise fuel, because you have to cruise to a different location
And
in the
night's
land.
45 minutes, but
Exactly right.
that's still cutting it pretty close.
Yeah, so minimum to fly this, 8.5 plus 6, we need 14.5 gallons, but we're going to take off more than that, obviously. But that's the legal limits of that. Good. Okay, that's the plan. We could take this piece of paper, we could go fly this today and make this happen. So let's get our iPads out and duplicate this whole process in the iPad. Okay, it won't take that long.
Okay.
You only have a phone, no iPad?
Yeah, I don't.
If you got it, great. If not, on your phone will work as well, Mark. No sweat.